There are roughly 20 quadrillion ants alive on Earth right now. Their combined dry biomass exceeds that of all wild birds and mammals on the planet combined. And they didn't get there by being simple. One species farms a single fungus crop underground, defends it with antibiotics grown on its own body, and ventilates the whole operation using wind-powered chimneys. Another builds its entire city out of its own linked bodies, tears it down every 2 weeks, and rebuilds it somewhere else. Another stitches homes from living leaves using its own larvae, has sewing tools. Another turns workers into living jars of honey and hangs them from the ceiling. And one has spread a single borderless colony across 6,000 kilometers of European coastline, from Italy to the Atlantic coast of Spain, with zero aggression between any of its nests. The largest documented ant colony contains over 20 million individuals. The oldest ant queens can live 30 years, founding entire empires from a single mating flight. And the most advanced ant nests reach 7 meters underground, with up to 8,000 chambers connected by tunnels engineered for two-way traffic. None of them planned any of this. No architect, no foreman, no blueprint. Every structure, every system, every caste was built by workers following chemical signals, one grain of soil at a time. This is every civilization built by ants. Deep beneath Central and South America, leafcutter ants, genus Atta and Acromyrmex, don't eat the leaves they cut. They carry fragments underground, chew them into pulp, and use it to grow a single species of fungus, Leucoagaricus gondolaphorus. The fungus produces nutrient-rich swellings, called gonolidia, that is the colony's only food source. Ants are one of only 4 animal lineages on Earth confirmed to practice true agriculture, alongside termites, ambrosia beetles, and humans. And they started roughly 50 million years before we did. A mature Atta colony houses 1 to 2 million workers, divided into size-based castes, tiny minims tending the fungus, mediae cutting and hauling leaves, massive majors guarding the trails. The queen can live 20 years. A single colony can stretch 600 cubic meters underground and process over 400 kilograms of plant material. But farming creates farming problems. A parasitic mold called Escovopsis attacks the fungus. The ant's defense, bacteria living on their own skin, pseudonocardia, that produce antibiotics targeting the parasite. They carry their own pesticide factory on their bodies. Where the soil is dense clay, millions of ants and their fungal crop flood the nest with carbon dioxide. Atta Vollenwaderi solves this by building ventilation turrets on the surface. Wind over the openings creates low pressure, pulling toxic air out and fresh air in. They don't just farm, they engineer the air supply for the farm. A city with agriculture, antibiotic defense, and ventilation engineering, built by eusocial insects following chemical signals in the dark. That's a civilization that never moves. Some ants took the exact opposite approach. No nest, no farm, no fixed address at all. In the neotropical rainforests, Asaton Berkeley builds no permanent structure. The colony, up to 2 million workers, cycles between a roughly 2 to 3 week statory phase, where the queen lays eggs in a fixed camp, and a nomadic phase, where they build a new camp nearly every night. That camp is the bivouac, a living structure made entirely from worker bodies linked by specialized, hooked feet. They form a dense outer shell, roughly 1.4 centimeters thick, against rain and predators, while the interior holds the queen and brood in a porous network of tunnels. It's not just shelter, it's a thermodynamic organ. Despite tropical temperature swings, the living mass holds the core at a stable 28 degrees Celsius, optimal for larval development. Workers contract or expand the lattice to trap heat or allow ventilation. Their entire city is made of citizens. The Old World version is bigger, much bigger. Driver ants, genus Borderless, across Central and East Africa, form the largest ant colonies on Earth. Borderless wilverthi has been estimated at 22 million workers. Their queens are the largest of any ant species and can lay 1 to 2 million eggs per month. 22 million ants. One colony. No permanent home. Architecture made of bodies, but one civilization builds from something even stranger, the silk of its own children. Up in the tropical canopy, Oecophila builds its civilization from living leaves and larval silk. Only 2 species exist, one in Asia and Australia, one in Africa. Workers pull leaves together to form nest walls. When the gap is too wide for a single ant, they form living chains, grabbing each other by the waist to bridge the void. They lock their joints and step backward, drawing the leaf edges together, a collective biomechanical system researchers call a force ratchet. Then other workers carry nearly mature larvae to the seam and tap their heads against the leaf edges. The larvae secrete liquid silk from their labial glands. Workers shuttle each larva back and forth like a living bobbin, weaving thousands of threads to seal the nest shut. Those larvae never spin their own cocoons. Their silk is spent on architecture. As the silk ages, it becomes hydrophobic, waterproof against tropical monsoons. A single colony can span dozens of trees and house 500,000 workers, and they defend the canopies so aggressively that Chinese citrus farmers noticed. In 304 AD, a botanist named Jihan recorded hanging weaver ant nests in orchard trees to kill pests. That's the oldest written record of biological pest control in human history, 1,700 years ago. The technique is still cited in peer-reviewed agricultural science today. Weaver ants solved the problem of shelter, but in the deserts, the problem isn't where to live, it's how to survive when every resource disappears for months. In the deserts of North America and Australia, honeypot ants turned their own workers into storage containers. During abundance, foragers collect nectar and honeydew and feed it to specialized nestmates called repletes. The replete's abdomen stretches until its armor plates separate, swelling the ant to the size of a grape, holding up to 112 microliters of fluid. Heavy, fragile, immobile, hundreds of repletes hang motionless from the ceiling of chambers dug up to 3.6 meters underground. When drought hits, workers tap them, and the stored liquid flows out through trophallaxis, mouth-to-mouth transfer, living jars, drained on demand. This solution evolved independently multiple times and completely unrelated lineages. Myrmecocystus in North America, Camponotus inflatus in Australia, and others. Different species on different continents arriving at the same improbable answer, turn a worker into a jar. Aboriginal Australian communities have harvested Camponotus inflatus as a traditional food for thousands of years. The honey holds cultural and spiritual significance, including the honey ant dreaming site in Central Australia, shared across multiple indigenous groups. A living practice, not a historical footnote. Honeypot ants store liquid. Harvester ants stockpile something harder to manage. Pagana the harvester ants of arid North America, don't grow food. They hoard it. Their nests are helical shafts descending 2 to 3 meters, connecting up to 150 chambers. One study found a single colony storing 58 different seed species from 20 plant families. The problem with storing seeds underground, they sprout, so the ants bite off the radicle, the embryonic root, killing germination while softening the casing. Major workers with oversized mandibles crack the hardest shells. Smaller workers chew the endosperm into a nutritious paste. The whole operation runs on counterflow logistics. Excavated sand moves upward, while foraged seeds move downward. Two opposite streams of traffic in the same tunnel system. No supervisor. No instruction from above. A red harvester ant colony's lifespan is tied to its single founding queen. She can live 20 to 30 years. One queen, one underground granary, 3 decades. Harvester ants prepare for drought. Fire ants face something they can't prepare for at all. When floodwaters hit the native range of Solenopsis invicta, the river basins of South America, the colony doesn't drown. It floats. Workers link bodies into a waterproof, buoyant raft. A single fire ant in water often drowns. Linked together, the colony floats for days. The ants on the bottom survive by trapping air against hydrophobic body hairs, breathing underwater. But the raft has a requirement nobody expected. Larvae. Without brood present, workers can form the structure but can't break free of the water's surface tension. The colony's young aren't cargo. They're a structural component of the raft itself. And a 2022 Georgia Tech physics study revealed something else. Individual ants don't cooperate at first. They flail, bounce off each other, try to separate. The raft self-organizes, order from chaos, shaped by physics, not intent. Solenopsis invicta is now globally invasive, reaching the US in the 1930s and confirmed established in Europe for the first time in 2023. Near Syracuse, Sicily, fire ants spread by accident. But one species did something far larger. It accidentally became the biggest society any animal has ever built. In their native range, Argentine ants, Linapithema humale, behave like normal ants, separate colonies, territorial aggression, clear borders. Then, they went invasive, and the borders vanished. A genetic bottleneck stripped the founding populations of specific cuticular hydrocarbons, chemical scent markers used to tell nestmates from enemies. Without that recognition system, every nest treats every other nest as home. The European Maine supercolony spans roughly 6,000 kilometers of Mediterranean coastline. Researchers called it the largest cooperative unit ever recorded. Then, something stranger emerged. Workers collected from the largest supercolonies on separate continents. California, Europe, Japan, New Zealand, Australia recognized each other as nestmates in aggression tests. Same genetic profile, same chemical signature. Researchers describe them as a single, intercontinentally distributed megacolony, though not every population fits the pattern. The southeastern U.S. Argentine ant population is aggressive and multi-colonial. Not every border disappeared, and there's a dark mirror to empire building. Some ants skip construction entirely and steal someone else's civilization. Polyergus, Dilotic, or Kidnapper ants raid formica nests and steal pupae. The stolen young hatch inside the Polyergus colony, imprint on its odor, and go to work. Foraging, nursing, building. For a species that can't do any of it for itself, remove the captured workers in an experiment, and the Polyergus colony starves. Its sickle-shaped mandibles can pierce an enemy's armor, but they can't pick up food. A civilization built entirely on someone else's labor, one that collapses the moment that labor is taken away. The last civilization on this list doesn't build, doesn't steal, and doesn't farm. Its entire defense is a single body part. Cephalotes, 119 described species across the neotropics, don't dig nests. They move into holes left behind by beetle larvae and tree branches. Their defense is anatomy. Soldiers grow an armored, disc-shaped head sized to exactly plug the nest entrance. One soldier parks its face in the doorway. The colony is sealed. The entrance is a keyhole. The soldier's head is the key. Every caste in this genus shares the adapted head shape, including queens, who use it themselves while founding new colonies alone. Pull the soldier away, and behind it is an empty socket. Push against it, and you're pushing against a shield that evolved for exactly this purpose. This defense, Phragmosis, evolved independently at least 8 separate times across completely unrelated ant genera, and even species without the disc-shaped head found a version. In the desert southwest, Phytol obtusospinosa evolved an oversized supermajor that blocks the entrance with its enlarged head as defense against raiding army ants. Different anatomy, same solution, 8 times over. The door is a face. And evolution built it 8 times. 9 civilizations, not one blueprint. A farmer, a nomad, an architect, a living jar, a hoarder, a raft, an empire, a thief, and a door. None of them planned any of this. None of them know they did it. 20 quadrillion ants, and these were just 9 of the ways they built a world.